can respond me.
Yeah, hi.
Madam, good, good afternoon, madam. Sir, I have not joined. Na?
Hi. Yeah, good afternoon. Tell me. Sorry.
Yes, madam. Is there will be any teaching today? Na?
Sorry, I didn't get you.
Madam, in this session, is there will be any teaching?
Yeah. I'm going to talk about neural networks. So that would be the last session. So I am just waiting for a few more students if they can join. If like not, I can start like
Okay, okay, madam. Thank you, madam.
yeah. So I think it's already 3:05. So I think I can start. Yeah. Let me share my screen. Yeah. So, hello everyone. This would be our last session, and today I would be telling about neural networks. So, initially, we have seen neural networks that how we can create neural networks, and from the scratch, I told you without using any library that how you can build your neural network, right? So in this sessions I will be dealing mostly about how you can like along with the already known packages you can work neural network on a real time problems. Okay, so I've shared the Google Colab link with you all, and yeah, I think I can start. So I'll just take few basic examples, and I want to show you how like from this point the deep learning portions comes in. So I'll tell you how the structure is mostly. So there's something called artificial intelligence. In artificial intelligence we have machine learning. Okay, so machine learning is basically sub part of artificial intelligence, and with machine learning there are different algorithms which we have gone through in the terms of our Python, which we have taken all different libraries and different some from the scratches. Then from there comes again a subpart that is called deep learning. So deep learning is mostly it's about different neural networks. So what neural network is, we have already deal with it. So I have told you how neural network works. Forward propagation, back propagation, how mathematics is involved in it, and how you can code the basics of those neural network, like the back propagation, forward propagation, the stochastic gradient, how to calculate the loss, how to know the weights, everything we have deal in the very scratch of neural network. So in the last session I would like you to know, instead of doing all those stuff, if you are familiar with your work problem and you know what is the problem you are going to deal with, you can directly import libraries, because nowadays that is which is more convenient. You should know what libraries is feasible and what libraries you should use to get a desirable output, right? So coming to that, again I will again stick to the same library, which is the very important library and which contains very good libraries of all the Python, that is Scikit. So today I'll be dealing with neural network with Scikit, how you can use Scikit. And Scikit, basically we have like most important libraries which we have deal with Scikit are these 4 5 libraries which can go along with any problems. One is pandas, one is matplotlib, one is your numpy. So these four basic libraries are there which you can come like again and again and again, which will keep coming. Okay, so yeah, again, so I have taken some random data. So I'm just calling because sklearn have some standard data set as well. So or you can say sample data set which is available for just to see how things work, how your algorithm will work. So there's something called make blocks. So it is a different color composition blocks which you will when call. This data set contains of different blocks which have different colors, so which that you can call your data set. Okay, so with neural network I want to know you about how you can train a sample using this data set that is called make blocks. So with sklearn I'm calling this make blocks, which this sklearn dot data set. The samples n samples is equals to 200, which means There could be thousands of data. How many sample do you want to work on? So I'm telling I need just 200 samples out of it. I need to work on 200 samples. See, when we talk about neural network, it's always about, like, you cannot work on the whole set of data. That doesn't make any sense. What I mean is, if we, okay, in a very general way, if we have thousands of dog pictures, we cannot train means what? We are teaching our model that these kind of features, if we'll find, will be a dog. So we are making them learn. So we cannot make them learn the whole set of data. Now your question will be, why cannot be? Because that will not make any sense. Because if you will get to know them, it's more of like, now I'm teaching you everything. You are learning a subject, and you also know what kind of question is coming in your examination. So how should one judge that you have already learned the subject? Because your mind knows everything. Your mind knows the subject as well. Your mind knows the questions coming in the examination as well, because you already know what kind of questions are they are coming and what should be the answers. So, like, no one can judge you that you are a master in that subject or not, right? Until unless you are taught a portion of subject, and that then from those portion of subject, relevant questions are coming to your examination, and then also you are able to answer them properly. So then someone can say, okay, now you know the subject. Similarly in machine learning, similarly in neural network, we do the same. So we have thousands of data. Among them, we take a portion of data, we train on them, and the remaining portion of data is used for testing to know if the model actually have learned it or not. And based on that, we calculate the accuracy. It's exactly like, on based on that, we calculate your results, like how exactly you know the subject, right? That is the example I can give. So I've taken n samples is equals to 200. These blob centers are like defining on the centers. Centers means how small or how large that data will be. So it is like height and width. Okay, so these are the 1 comma 1, 3 comma 4. So where is that in the data set? Okay, now I'm defining the labels, which is, and samples is like I'm giving 200. Centers is like these are the centers which I'm providing. Clustered standard is a mean cluster, that how many distance you want. Okay, for how distance you want one cluster from another cluster. And these are the colors which we have provided. Green you can change, obviously you can change it. So I need to know how my data will be plotted. So okay, yeah, this is what we get as the our result. So these four different colored dots, these are the clusters, four clusters, which showing the blobs, and these are on the basis of the centers we provide, the four centers we provide, right? So based on that, they have been represented. Now we are again doing the train test split, because we need to split the test size and train size. So this time I'm doing 60/40. Again, you can go for 70/30, anything, 75/25, anything, whatever ratio you want, you can do that. Okay, so I'm doing that. And again I'm doing the, now I'm using an MLP classifier. MLP is called multi-layer perceptron. So neural network work with multi-layer perceptron classifier. I hope you know, you're familiar with this thing. So I'm I'm fitting my data, and I'm calling this MLP classifiers. So I see this is the classifier which I've taken. What are the factors? Hidden layers I have taken 6. There's alpha, which is the weight value. I have taken what? E minus 0.05, which means around 0.001. And this solver is something kind of a, different methods, or different classifiers which you can use. So this is nothing to worry about. You can just learn about them, and you can use accordingly. So what generally I use is the default one, that is LBFGS. So it is a classifier. Now I need, now my, since the data has been fitted, it's a very small data which I wanted to just show how with Scikit, in just 2-3 code, you can do your like training of your model with neural network. So now I'm calculating the score, and this is for trained data. For trained data I'm getting score as 1, because Doesn't matter for training, it is fine. Like if you will change it, I think if I'll change it 0.3, the date results will be something different. So training it can come, right? So training it should come at least one. So it's more of like a joke. Whatever things you have taught in the class, that is the question coming in your examination. So you should know about that. What matters is to calculate the accuracy on test data. Okay, so that is what important is. Now we have to see on train data it is 1, that is 100%, but on test data it is 95%, right? So this score on test data is what it is important. Okay, this test data. So for test data you are getting 95% accuracy, which is pretty much okay, right? I'm doing the prediction on I'm telling that do the prediction on last 20 data. So this is giving the prediction. So this is just like which class it belongs to. We were having four classes, right? 0, 1, 2, 3. So these are telling ki last 20 data belongs to which cluster. That's it. Okay. So this was one example, and it's a very small example. It's a very small example. It's a very small network. The second data which I'll work with is a multi-layer perceptron. So now what multi-layer perceptron is? Single layer perceptron basically is I have one input or some hidden layers which will be having one neuron or two neuron, and then the output. Multi-layer perceptron means I have one input or more than one input. Then there will be different layers, hidden layers. In each hidden layer, different neurons will be there. I think I have taken a picture. Wait, I will put a picture. Yeah, something like this. See, so if you can see x0 and x1 is my one input. These are my what biases, okay, and these are my hidden layers. Hidden layer h00 01 02 03 04. So both of the inputs are connected to these all the hidden layers. Then again there is another hidden layer h1011, and then output, and these all are biases b0001. So this is what multi-layer perceptron means. Okay, so now we will be dealing with multi-layer perceptron. For multi-layer perceptron, again the same MLP classifier. I'm taking my there are two inputs, right? X001101. Y will be 0001. So this means this is the classifier which I should get the output. Others are 0. Okay. Again the same thing. I need to provide alpha. Hidden layers. What is there? 5 and 2. So you can see there are there are two layers. There are two hidden layers in which first hidden layer is of 5 and second is of 2, right? So this is what we have given. This this hidden layer 5 comma 2 is first hidden layer consists of 5 neurons, and second hidden layer consists of 2 neurons. Okay, and now I'm fitting my x and y. Okay, so my MLP classifier has been called with all these parameters that is needed to be done. Now I need to know the weight between input and first hidden layer. Okay, these like basic steps what we have done in the previous neural network class. Over here we'll be just calculating the values. So I need to know what is the weight between input, that is x0 and x1, and the first hidden layer, and again weight between first hidden and second hidden layer. So I'm calculating those. So that is represented as coefficient 0 and coefficient 1. So I need to know that. So these are the weights. These are the values, weight between input and first hidden layer, and the weight between first hidden and second hidden layer. Okay. Now again I need to know what will be the final weight. These are the different weights for C. What I meant is I hope you are familiar with neural network, how it works. So these are the weights we calculated individually. Then we calculated the weights between these. So how will be the weight? So this H10 will be having 5 values because of this. This H11 will be having 5 values because of previously we have 5 hidden neural networks, right? Similarly, if H00 we'll talk about will be having 2 values. So you got it, right? But when we finally calculate the weights, there should be one weight for each of them, that is W0 and W1, right? That's the final weight. So this is the values you were getting, right? So if we'll calculate that, what we'll get is W0 and W1. These are the values. These are the final weights which we get for first hidden layer and second hidden layer. Now I need to calculate the coefficient. So I need to know all the coefficients that has been provided from 0 to the final layer. So these are the coefficient. These are just the values I wanted to show how if you want to know each layer's values, you can do that as well. Okay. We can generate the above to access a neuron in the following way. If you want to access all the neurons, there are different neurons, right? 00, H00, H01, H02. These, if you can see, H03, H04, right? Similarly, we have this also H10, H11, and then final output. We can consider it as H20. So if we want to know the values of all these neurons, how we can do is we are calling, because what are these? These are coefficient only, right? We are termed as coefficient. So we are calling at CLF dot coefficient for all the coefficient. So we have kept as I. So we are telling number of neurons in layers. Just take it as I, and with each iteration reduce it and calculate the value. Okay. So okay, this is the value. So for H00, the value is minus 0.14 to minus 0.69. For H01, these are the matrices, right? You can understand. These are the matrices and these are the values which has been calculated. Okay. Okay. And why H00 have two values? Can you guess it? Okay, can someone will tell why H00 have two values and H10 have 1, 2, 3, 4, 5 values and H20 have again two values? Can someone explain it to me? I hope I'm audible, right?
Yes, ma'am.
Yeah. So can someone tell why H00 neuron have two values, H10 have 5 values, and again H20 have two values?
Hidden layer values.
Yes, but what like?
H2 consists of five hidden layer, five values.
Okay, okay, um, okay. I'll tell you. See, can I take it a little bit lower? Yeah, yeah. So just see these values, okay? So H00, this is H00, right? You can see my cursor, right? Yeah.
Ma'am.
So this is H00. So H00 is taking values from X0 and X1. That is why it has two values. If you'll talk about H10, which is having 5 values, it is taking values from these 5 inputs. For H10, these are the 5 inputs. H00, 01, 02, 03, 04. That is why H10 have 5 values. Similarly, H11 have 5 values. And again, if you will go down, your which is 20, which is your output, nothing much that but it output. So that H20 have again two values. Why? Because if its input is H10 and H11. I hope I'm clear.
Yes, ma'am.
Yeah. So I just wanted to show how even with this predefined libraries, at every step you can know what are the values feed getting to them or what are the values being feed to them, and if you want you can modify them. Okay. Yeah. So going back again, so this is what we talked about, weights and hidden layer values and everything. There's something again called biases. These yellow color blocks, circles, B0001, these are called biases. So now I need to know again the values for first hidden layer bias, the values for second hidden layer biases. So these are called, we have termed it as intercepts. These are nothing like, straight lines. So x is equals to mx, right? Y, what is exactly y is equals to mx plus c. So y is my m is my this coefficient or slope, and c is my intercept. So similar to that, w or these values are called as coefficient, and b, y, biases values are called intercepts. So I've calculated the intercept or the biases values for first hidden layer and second hidden layer. Now again, it's the same thing. I need to calculate the values for all the methods. So I'm doing the predictions, and instead of just looking at the class result, we can also use the predict probability method to get the probability estimate. Okay, so we can get the probability result that what percentage of this belong to that class or what percentage of this belong to this class. So these are the probability in terms of probability. Okay. So this was one example where I wanted to show how for each layer in multi-layer perceptron, you can know the values. Okay. Now, for this, again, you should know that if we are taking a proper data set, how each step should be and how you can directly go without knowing what are the inputs and outputs, layers, hidden layers. We don't need to know this if we are working on a very big problem. Okay. Or sometimes we need to know depending on what kind of problem we have. So again, the most used data set I'm taking, which is iris data set, which is again, like that consists of those flowers data set, right? So I'm taking the iris data set from sklearn. Let's run them, splitting the data set again into training and testing side. Over here I've taken 80 to 20 ratio, 80 training and 20 test data. Okay. Now there's something called scaling the data set, which we have been doing it. Why we need to do it? Depending on the data set, because some data sets are not in the same range as your previous data set. So we need to scale them. What I mean is, for example, if one data set ranges from 1 to 100 and one data set ranges from 1 to 10. So you need to either take this 1 to 10 data set to 1 to 100 or 1 to 100 data set to 1 to 10. And then only you can do the any comparison. So that is what we always do. We need to do a standardization scaling. Okay. And after this scaling, we need to do the fitting of training data, and then we need to again do the scaling for train and test data. Okay. So I want to see how my train data is. So I just put that last three data. You just show it. Colon 3 means last three data. So these are the last three data which they are showing. Okay. And why the four values? Again, three rows but four values, because the data set we have taken is iris data set, and in iris data set we were having four target classes. Okay. Now again, I'm training the model with MLP classifiers. I'm taking the hidden layer as 10 comma 5 means my first hidden layer have 10 neurons, my second hidden layer have 5 neurons. Okay. And maximum iteration means 1000. Iteration means keep iterating it. Matlab, I mean meant is, if you have done once the entire process of calculating the weight, bias and everything, do that 1000 times. Sometimes these thousands are very much, you depending on amount of data you can do it. Since iris data is not that big, so 1000 iteration is good enough. If there is a more huge data set, then we have to bring in picture the batch set. Remember I told you that you have to, if you have a lots of uh, data, you have to cut it into different parts and then do it. So what we do is, if instead of this iris data set, if we have a much larger data set, then we will cut the data set into batches, and each batches will be done with some particular iteration. So now we don't have that thing, we are directly putting the iteration. Okay. And after the iteration, we are telling that fit the training data to our model. Let's run it. So yeah, it's been done. Then we are calculating the accuracy score. Accuracy score again is important. Let's do it. This is for training now, so it's better if I write. Wait, let me just modify something. Train and test. Yeah, so it will be easy to know which is training and testing accuracy. Okay, so we are getting train accuracy as 0.98, that is 98%, and test accuracy as 93%. Okay, now I'm calculating the confusion matrix again. So I'm again, okay, let me write confusion matrix also where. Yeah. Okay. It will not take it. Okay. Okay. So this is the confusion matrix which we have calculated. Okay. So for the training labels. So this one first confusion matrix is for training level. The second confusion matrix is for testing level. So the training level is fine, but most important is my testing level confusion matrix. Okay. Okay, okay, let me run this as well. Now, again, the classification report, obviously, we have to get a classification report in which it will tell about all the three classes, their procedure, recall, what are the F1 score. These are just the evaluation matrices which is needed to be done. And again, the accuracy, macro average, weighted average. So this is just a classification report which is needed. Okay. Now, I have taken a quote from this author Isam H. Laradzi, which is a very good author who works in neural networks and different examples. So they have taken a very good example for a neural network and how they have done the programming in one para. Okay, so I have even put the like you know this I'm sorry, the link from where I have taken the code. So you can go anytime or to that link and see. I have taken this data set because I wanted to show that since we are doing like this, every cell we are writing one few code, because I wanted to see how every line works in. But that doesn't work when you work for a longer data set. So this is just see the coding in one cell itself. He have coded everything, right? See, he have coded everything with the numbers or the hashtag. Okay, this is this is this. So with different alpha values, how my values is changing, he have shown that. So I wanted to show you this thing, and that is why I've taken it. So he have just used sklearn, nothing else. So I've taken all the libraries from sklearn. He have taken the step size. Step size is the iteration size only, nothing much. Alpha, how he have taken, how he beautifully he have written the code with all indentations and everything. That is the main purpose of taking this code from his library, and to show that with single thing, with single library, and with one cell, how you can write your code. So this is the way you should write your code. You should know after which step what coding should be done and what needed to be done. Okay, so this is what one thing I wanted to show you. Take time to run, but this is a very good code. If you want to know how the coding exactly works, what are the steps needed to be written, and when you will see it, you will get to know that this is exactly what we used to do. But we used to split our coding after every line. Okay, this first we have called all the libraries, then we will call the classifiers, then we will call the data set, then we will call the fitting, call the scaling of data set, fitting of data set, splitting of data set, training of data set, and then the plotting, right? That is how we used to do. He have done everything in one, and very beautifully he have done it. So this is he is showing. Okay, over here he is showing this alpha values, different weight values, how the different weight values is like distinguishing these two clusters. And these 0.93, 0.85, these are the accuracy he is showing. Okay, what is the accuracy he's getting out of everything. Okay, now again another example which I'm taking is digital data set. So how to identify different digits. Okay, so again I'm calling that digits data set from its dictionary itself. And the digits data set have what kind of keywords? Data, target, frame, feature names. These are the keywords that is having. Now I need to know how many samples are there and how many features are there. So that is what I'm calculating, the number of, basically it's shape. So it have 1797 data with 64 different numbers. Okay, now I want you to see at zeroth position what are the values present. So this is what we are talking about. So how we do is we do in a step by step. It's in a way to good to do this, because you get to know what are, how to proceed with your program, how to go step by step. Okay, now I'm doing this. What are the target values present? So we can see 0 to 9, we have the target values present. Now we need to know the shape of an item. So we are taking the 0th point. What is the data type of an item? Like what kind of data type it have? It is an integer, float, string. What is the shape of an item? How many values does it have? And again, what is the data type of it? So what we can see is we have 64 data shape, 64 items, which data type is numpy, means it's in array. And again, the for the digit images, data have 64, images have 8 cross 8, and which makes it 64, right? 8 into 8 is 64. And again, what is the data type? The nd array. Now I'm plotting the figure of the same. So we are taking the images of data set for the zeroth number. So obviously we know zeroth number is the zero itself, so it is showing the image of a zero. Okay, now I'm plotting the figures. I'm telling from 6 to 6, draw all the figures which is present in the range. What we have, 64 datas, right? So I in the range of 64 for each images, which is 8 cross 8. So for all the 8 cross 8, draw the images, and we have to see the our data which is present in it. Okay, so we can see these are the numbers 0, 1, 2, 3, 4, 5, 6, 7. So this is from 0 to 7, but this is not the case for other. So we have different images. We need to identify what kind of data set it has. Now again, we are plotting the matplotlib, and in that, what I'm doing is I'm dividing it into 12 cross 12. Initially it was 8 cross 8, now it is 12 cross 12, which makes it 144. If you'll see, now it have 12 rows and 12 columns. Okay, and we want to see how my data set is plotted in that scenario. So instead of 8 cross 8, which was initially there, that is the case, we have 8 rows and 8 columns. We are now dividing it into 12 cross 12. Okay, now I want to train my model, split it. Again, the same thing, calling MLP classifiers. Hidden layer, I have given 5. It's just one hidden layer. There's something called activation function. Activation function is needed when there is non-linearity in the data. Non-linearity means, again, linear means what? There are two data set which can be just with a single linear line, it can be separated. Non-linear is if the data set, okay, so if I'll go back, okay, this kind of data set, which you can see, is a non-linear data set. It cannot be separated just by a single line, right? So these are non-linear data set. So to handle these kind of data set, we need some activation function. So for we have taken the logistic activation function, okay? And these are different again, the alpha value, learning rate, etc. So we want to fit our model. We want to train our model. So with different iterations, see, 57 iteration, and it is calculating the loss. I'm going to show you one very good important point. See the loss. For iteration 4, the loss was 1.4. If we'll go down, how the iteration, with each iteration, how my loss is decreasing. Can you see? My loss is decreasing. So you can say like little bit will increase, decrease something. So we can see training loss did not improve more than total 0.0010 for 10 consecutive epochs. They saw that after certain time, this loss is not much increasing. So they stop it. They, because I'll show you. We'll go back. How many iteration we have given? Where is the iteration value which we have given is? Okay. Just a minute. I need to show you the iterations which we have taken. I think we have taken iterations, default iterations, which is of like 100. I think we have taken default iteration of 100. But instead of going for 100 iterations, it stopped at what? Around 57. Why? Because after 57, it is getting saturated. There is no much further decrease in my loss. So that is what they have written. The training loss did not improve more than total this now for 10 consecutive epochs. That is why they are stopping the iterations. Okay. That can also happen. That is not an error, not at all. Now we can do the predictions on our test levels, and what we need to calculate the accuracy on our test levels. So we can see 82%, which is pretty much good, right? For a data set like this, digit data set, which is a huge data set, getting accuracy like 82% is pretty much good. Okay. If you want to get the predictions for different compositions. Like over here, I've taken from 5 to 35. I need to know what kind of results I was getting. Okay, so it is showing results for that in terms of probability. See, for 5 it is giving 82%, for 6 it is giving 90%, 7 77%, something like this. Okay, it will calculate because the range we have given is 5 to 35. You can choose your range. I have taken 535. You can change, take anything, whatever you want. So it has given from 5 to 35. 35 means obviously 34, right? Because it will count from 0. So it is giving all the accuracy report from 5 to 35. Because what my data set was, I what 12 cross 12, that is 144. So we have huge data set. So we can take whatever accuracy for each numbers you want. So yeah, this is what neural network with Scikit is, and like I hope this sessions or this introduction to machine learning with Python have cleared most of your doubts regarding your coding things. So if you guys have any doubt, any issues, let me know. And I hope I have covered most of the part. Yeah. Anyone wants to say anything? Like I don't know. Like, see, I would, if you would ask my suggestions for, going for this programming with machine learning, I would just say start with the basic. Start doing with a very basic problems, even with, adding two numbers to working on certain data set which are very freely available. Work with any available data set. Work with, there's a platform called Kaggle. I would highly recommend it. I'll just write it on chat box. Kaggle. So this is a platform where you can find different kinds of data set, different kinds of code, and when you stuck somewhere, no, just look for similar kind of solution. You may not get the exact solution, but most of them are available. There's one more course I would suggest. If you are free, you can anytime go and work on this. There's some which actually helped me for the Python programming, which is Coursera. Okay, and there's another fast.ai. These two I would highly recommend. So these two are courses which will provide good course content in terms of Python programming. So I would say just start with the basic, and eventually you will never know when you will start working on a big data set. So it's not at all a difficult. Python is much much easier than C++, Java. Like at least I feel it. Okay. So yeah, I hope like you guys will do well. You will be having your examinations. So all the best for that. And yeah, anyone have any questions, any to ask? Please feel free to do that. Okay. Okay, then I'll wish you guys all the best and prepare best for your exam. And don't worry, the questions will not be that tough. And you guys will do well. And it's not about the examination and passing the course, it's more about learning. So I hope we are able to do that. And if you have any problem in future, just ping me, or you can comment on my YouTube videos, or anything which you have, you can just reach out to me at any time. Okay. Okay, then see you guys and all the best.